Hello there! In this lesson we are going to be concentrating on algebraic expressions. Now, algebraic expressions consist of one or more variables. What's a variable? Well, a variable is a letter that represents a number. A lot of times mathematicians like to use x and y. Sometimes we use n, but any letter that represents a number, sometimes it matters, sometimes it doesn't. A constant is a number in an expression that does not change. So in an expression, this will be a number that's added or subtracted that isn't attached to a variable. It does not vary. To evaluate an algebraic expression, substitute a given value for the variable and carry out any necessary operations. You will be asked to evaluate in some of the work that you're going to do and in some of these notes. So it's important to know what evaluate means. So we're going to begin with this first example. Miss Kimball was born in 1984. True story. To find out what year she turned 16, you can add 16 to 1984. So it would look like this, and this is an expression. It's not an algebraic expression because it doesn't have a variable, but it is an expression. 1984 plus 16. Well, if I wanted to evaluate that, well, I would just add the two together, and I could tell you that that was the year 2000. So I have just evaluated that expression. Now, a variable can be used to represent Miss Kimball's age during any given year. So during any given year, that is 1984 and beyond, we can find out what year it is if you plug in my age in that year. So that would look like 1984 plus A, and that would, if you were to plug in my age, again, it would equal that particular year. So here's an example. Write and evaluate an expression for the year Miss Kimball will turn 30. So we would use this algebraic expression, 1984 plus A. But if I wanted to know what year I would turn 30, I would plug 30 in for A. I would substitute it, and that would look like this, 1984 plus 30. And that year, which is approaching very soon, is 2014. So there will come times where you will be asked to write algebraic expressions. When writing an algebraic expression, I want you to think about the story and then manipulate the numbers and operations and variables until they fit the story. It isn't about coming up with the right answer right away. It's about making sense of what you are being asked to do. So here is a short example. If you were asked to write an algebraic expression for 3 less than a number, you have to kind of go through a thought process. Well, what is unknown? A number. We don't know what that number is, so we can give it a variable. I immediately think of x, but I put a note on here. You can use y or t or b. In an instance like this, it doesn't matter what variable you use to represent that unknown. Well, what do you know? 3 less than a number. We've already said the number is x, so we know that it's now 3 less than x. So what does that mean, 3 less than x? Does it mean x plus 3? Does it mean 3 minus x? Does it mean x minus 3? It could mean a number of things, so let's put ourselves in this situation. Try to connect to what's asking you and say 3 less than x. Well, if I know what x is, let's say x is 10. What's 3 less than 10? 7. How did you get that? Well, you did 10 minus 3. Well, if 10 is x, then my expression is going to be x minus 3. So again, this is the thought process I want you to go through when you're thinking about writing these algebraic expressions. What story is being told, and how can I connect to this story? Here are some examples that we're going to work through together. Write as an algebraic expression. Example A, the product of 7 and p. Well, the product means to multiply, and so I would say the product of 7p, well, that's 7 times p. We know that multiplication is commutative, so it would not be incorrect if you were to say p times 7. This is not always going to be the case. Some operations are not commutative, so just be careful and know which ones are and which ones aren't. Example B says 3 times the sum of a number and 5. We have a couple things going on here. We have 3 times the sum. Sum means to add together. The sum of a number and 5. So first I have to say, well, this number I don't know. I know is being added to 5 because it says 3 times the sum. If I want to multiply by the sum, I need to make sure that the sum happens first. Well, what can I do to make sure that the sum happens first? When I plug in a number for n, I can put it in some grouping symbols or parentheses. Now I multiply the sum times 3, and that will be my correct answer. Again, multiplication is commutative, so your answer could look like 3 times n plus 5. Okay? And again, the variable letter you use doesn't matter in this case. Example C, the quotient of a number and 3. Quotient means division, so I'm going to say the quotient of a number and 3. Well, there are 2 possible things I have going around in my head. A number divided by 3, or 3 divided by a number. Is division commutative? It is not, so I have to go in the order they give it to me. The quotient of a number and 3, that's going to be a number divided by 3. Division can also be represented as x divided by 3. It can also be represented as x divided by 3. Okay? And then example D is 14 less than k times 6. Again, more than one thing going on here. 14 less than what? K times 6. So I'm going to say k times 6, and I'm going to say it looks like that. That's okay, because multiplication is commutative. 14 less than that. You might want to say 14 minus that, but you have to think, what's going on? 14 less than k times 6. Well, if k was 4, for example, k times 6 would be 24, because you would multiply 4 times 6. And then 14 less than 24 would be 10. You have to take 14 away. So subtraction's not commutative. You can't say 14 minus 6k. It's 14 less than k times 6. So it's 6k minus 14. I caution you when you approach subtraction and division to truly take a step back and evaluate for a second what you're doing and what order it goes in. Connect to the story. I promise it will help you. Now I'm being asked to evaluate each expression for the given values of the variables. So I need to substitute these values in and then combine the terms or solve as far as I can to get some kind of answer. 5y minus 1 for y equals 3. Well, if y equals 3, I'm going to substitute it in for where y is in my expression. So that's 5y, which I know is 3, minus 1. Notice when I substitute, I do so in parentheses. I do that for a reason. Then I follow my order of operations. 5 times 3 is 15, minus 1 is 14. I can't go any further. That is my solution. P divided by 7 plus P. Sometimes you'll have a variable more than once. Well, you still plug it in. P represents 14, so I can say 14 divided by 7 plus 14. Just keep in mind your order of operations. 14 divided by 7, and I'm just coming over here. 14 divided by 7 equals to 2, plus 14 is going to be 16. So there's your solution. 16 divided by k plus 7h for k equals 8 and h equals 2. No need to panic. We know the value of both of these variables, so we're going to substitute. 16 divided by k equals 8, so that's 16 divided by 8, plus 7 times h is 2, so we'll plug that in. Division and multiplication going on here. Go from left to right, evaluate them in the correct order. 16 divided by 8 is 2 plus 14. Now I add them together and I get 16 yet again. Lastly, we have a bit of a problem-solving scenario here. The expression 60m gives the number of seconds in m minutes. Evaluate 60m for m equals 7. So what you're being asked to do is find out how many seconds are there in 7 minutes. I already know what to do because it tells me. Evaluate 60m. 60m for m equals 7. And it says evaluate, which tells me I need to substitute and then complete the operations. 60 times 7. I can come over here and do it, or I can use maybe some mental math. I know 6 times 7 is 42, and I know that this is 6 tens. That's what 60 is, so I can multiply 42 by 10 mentally. So I know my answer is going to be 420. If you want to make sure, I can come over here and say, okay, well 60 times 7, 7 times 0 is 0, and 6 times 7 is 42, giving me 420. So there are 420 seconds in 7 minutes.